Did you miss me last week? Well, when we were here together 2 weeks ago, I was describing the new breakouts that were occurring right near the abandoned geothermal well site up in the crack system. And I had indicated that those breakouts had not traveled out of the crack system 2 weeks ago. And of course that changed, that's changed in the last 2 weeks. There have been quite a few changes to the new lava flow that is now moving downslope. As you see in this image, moving downslope to the north side of the old flow. So let's go to the next slide here. So can everybody see that okay? Is there too much light? Too much light. Maybe we could dampen some of these. You can still see? Okay, great. Okay, so we're looking at the new activity above Apaa Street, and we're looking up toward the crack system, which is right up in here. Pu'u'o is in the top right-hand corner. This is the original lava flow that moved down slope toward the middle of Pahoa. And this is the new lava flow that originated from a breakout here and moved down through the crack system and moved on top of this flow and along the north margin of the flow, and now is completely on its own, moving down slope along another blue line, another path of steepest descent. And so we'll talk a little bit more about those breakouts that occurred and how they've organized themselves into a single flow now. And the flow is moving right now down the steepest part of the slope between this area and the crack system. So it's been moving relatively fast as 450 yards a day. But it looks like it might be slowing down already. So I have three main points to make, that the breakouts from the crack system that started on November 19th have developed into an organized flow, and it is moving down slope on the north side of the earlier flow. Number two, the flow is moving north. It's following a new steepest descent path, another blue line, but the future path is uncertain, and I'll tell you why in just a few minutes. And the advance rate will likely decrease and become much more variable than it has in the past week or two. It has been moving pretty consistently, pretty near 400 to 450 yards a day. And like we observed during the activity in September, late September, when the flows were moving that fast, a little faster, and then slowed down, we expect this flow to also slow down and the rate to become much more variable, which means that when you try to calculate travel time of the lava flow to a certain location, certain distance, it's tough doing that because the rate changes day by day or every few days. So that means that when you try to make these calculations, and I'll show you a couple, they're not very certain. You can't place a whole lot of confidence in those numbers. So let's back up just a little bit to set the context for this current flow. On November 14th and 15th, it was a Friday night, Saturday morning, the lava tube that was delivering lava to the lava flow in the middle of Pahoa basically sprung a leak way up at Pu'u'o. And from that location, a breakout occurred there where the white line went out, and there was also another lava flow that went out to the south side and then circled back. And in this image, that lava flow was prevented from going to the south by this ridge here, you might say. This is the perched lava pond that formed in 2007 during an eruption from vents located at the base of Pu'u'o, or just to the east of Pu'u'o. Okay, so these breakouts essentially took all the lava out of the tube, so that the lava that was in the tube eventually drained out, fed some of the breakouts in the middle of Pahoa and up above Apa'a Street. But within a few days, there were no more breakouts from the old lava tube system. Well, at the same time on Saturday or Sunday, the 15th or the 16th of November, there were a series of new breakouts that occurred from the lava tube downslope, and we've marked these here on this map. Here's Pu'u'o'o. Here's the red, the original lava flow down through the crack system here and out of the crack system to the north. The first big breakout on the 14th and 15th occurred right in here. And then lava made its way back into the tube system. And as the lava flowed down through the tube, some of that lava leaked out onto the surface to form a series of small breakouts at these locations. And then on the 19th, lava finally appeared down through the crack system and right next to the abandoned geothermal well site right here. So that was indication clearly that the tube was open enough to allow the lava to continue its downslope movement from Pu'u'o'o, but then it got stuck right here. Lava didn't break out from the tube system any further downslope. So this is an image taken by volcano helicopters on the 19th. And here's the abandoned geothermal well site over here. This little circle shows you a little helicopter. You believe me, that's a helicopter. And the breakouts occurred from this part of the lava tube. I think I have, so there's the crest of the lava tube. It's formed by a little pressure ridge there, a tumulus. And lava came out both sides of that lava tube. So this is the slide that I showed you 2 weeks ago. So if we skip ahead another 5 days to the 24th, that's a week ago Monday. Here's Pu'u'o'o. Here's the abandoned geothermal well site. Here's the area of the breakout. I put a circle here. And those breakouts then formed a series of flows that spread downslope along the crack system and then moved toward the north. And I put several arrows here to indicate the pathways of many different breakouts, sort of individual flow segments, you might say, because at the end of each of those you see the burning smoke, and that's where indication that the lava is directly burning vegetation. So that's where the active flow is. So in this image, if we look at this image in infrared, with an infrared camera, it looks like this. So you can see that there are many, the very hot colors, the white and yellow, are the very hottest temperature on the surface. And these areas are the areas of the active part of the flow. So you see there are many active breakouts occurring along here, along many different areas, back here, all along the surface, and so on. If we look at the current flow earlier this week, that is on Monday, December 1st, particularly with the infrared camera image, it looks very different. The flows have all sort of merged and are feeding one main channel, one main flow. This is relatively narrow still, less than 50 to 100 meters wide. This is what the image looks like with a normal camera. In this particular image, you see this little bright streak right here. This is the active lava stream that Daryl was describing on his daily reports. And that was an active lava channel in the process of forming a lava tube that is now tubed over and very likely is providing a nice pathway of lava through that new tube down to feeding the flow front. The lava here actually split, so there was an active flow that went around this way and this one, and then they merged a little lower down slope. I think I can show you this in this image. This is an image that Daryl took this morning during his overflight. And just to kind of orient us a little bit here, this is the older lava flow that went down off screen here into Pahoa in Apa'a Street. So we're looking kind of up toward the crack system back here. And here's the new flow that's found its way down through the forest. This is the area where it split. You see this little kipuka here. So lava apparently is flowing along both sides and then feeding lava here at the flow front. And you see it's just to the north of the older flow, the original flow that came through earlier. So if you've been experiencing a lot of smoke from time to time, this is the reason why. The flow is moving directly through a new part of the forest. Lots of vegetation, it's very wet, so there's a lot of smoke being generated along the active flow fronts. Okay, so let's go to a map view. Just for orientation again here, the red area is the addition, new lava on the surface between November 24th and December 1st. So that's 1 week. A week ago Monday to earlier this week Monday. And what's apparent is this lava flow then that is moving toward the north, and you notice that it's following almost exactly one of those blue lines, one of these paths of steepest descent. So at least for initial flows that cross new ground, those paths of steepest descent are a very good indicator of where the lava flows are likely to go. And keep that in mind. For the very first flow that moves across the ground in a new area, the blue lines are a pretty good indicator. Okay, so since Monday, the flow has traveled this distance to that point right there. And just to the north of that point, you notice that there are two blue lines, paths of steepest descent, that get very close together. And that is a tip-off that that area, the program couldn't really quite decide which way the flows are really going to go. And so there's a certain amount of uncertainty here as to where the lava might go. And at the current rate, or the rate the flow has been moving the past few days, from say 400 yards a day to maybe 160 yards a day that Daryl measured yesterday, between yesterday and today, the lava should arrive at that sort of juncture point in the next few days. And we could expect the flows to slow down in that area. They might pond up, they might start spreading out one direction or another, depending on what that microtopography might be in that general area. And microtopography, I'm thinking anything that's less than 2 or 3 meters high can help to nudge the flow one direction or another initially. So it may take a few days after that, maybe a week or so before, maybe a couple weeks before we get a clear sense of the potential path, the likely path from that point forward in the coming weeks, if the lava flow keeps moving. If lava is still being supplied through the lava tube, down through this new tube system, and to the flow front. Okay, I want to back up here. So let's take a look at, I wanted to give you an idea of what this area looks like from the air. So we're going to take a photograph of this area right here from the air. And you notice this little green patch here, just at the bottom part of that circle. That's a vegetation band. And so if we take a look at what that looks like from the air, we're looking upslope toward the crack system. Here's the smoke from the forest along the edges of the lava flow. And this was a photograph taken on Monday, the 1st. And here's that little green patch of vegetation right there. So you notice it's pretty flat, looks pretty flat in there to the visual eye. There is a bit of a slope there. It's only 1.5%. But it's not very clear at all, just by looking at this, as this flow comes through here, what direction it's going to go. Okay, so let's take a look at this map. This is a familiar map again, looking at the whole eastern tip of the island with the full length of the lava flow from Pu'ua'o down through the crack system out to the north to Pahoa, and also this new lava flow then that's branched off and is flowing to the north right here. So there's that area of uncertainty. What's going to happen downslope of that once the lava reaches there and makes its way one direction or another. But what I've done here is to emphasize those blue lines with a bolder line so it's a little easier to see. So there's the possibly two separate paths that the flow could take. This one takes it right through to the intersection of Highway 130 and Pahoa Market. And this one will take it up to the north and cross Highway 130 south of Paradise Park area. And so if we mark the distance along those marks, so once the lava gets past that flat area, gentle area, where those two blue lines are close together, from that point to the highway, it's 2.2 miles if it takes that southerly route. If it goes the other way, it's 3.8 miles. And it travels through even gentler slope ground as it gets out into this area. So if we now take a look at the advance rate over time of the flows that we've been observing for the past couple of months, what I've shown here is a plot that shows us months at the bottom, September, October, November, December. And on this scale is the advance rate per day from 0 to about 500 meters. So if you're at 400 meters a day, that's about 450 yards, roughly. So just want to walk through this just a little bit. So this is showing us the first data point on September 3rd when the lava emerged from the ground cracks, at the lower end of the ground cracks, and then started to move to the north down the steep slope. And you see it shot up to over 400 meters a day, then it slowed down, shot up again, and it eventually stopped on about September 19th because the discharge from Pu'ua'o changed to about 25% of what it was sending through the lava tube. Lava then started breaking out behind that flow front, upslope. And when it finally made it past the flow front, then we had an advance rate. And you notice here how much lower they are. And then, of course, when the lava took off down the gully toward Apa'a Street, the advance rate shot up to 500 meters a day and then slowed down. So here are the advance rates for the new flow once it got out of the crack system. And you see that it has varied quite a bit from almost 500 meters a day to about 160 meters a day. And so I thought I would just to set a little context so there's an uncertainty about what the flow path will be if the flow keeps moving down slope past those two blue lines. And there's, depending on what path it takes, there's a different distance. And with these kind of varying advance rates, what kind of arrival times might we be looking at? Now, before I show you these, how many of you think the flow is actually going to follow what I'm going to show you? Anybody? Okay, not even 2% of you. Okay, but I think it's helpful just kind of to have a context for what maybe some options are. Okay, so at the 2.2 mile path, okay, once it gets past those blue lines and it starts making its way down toward the Pahoa marketplace, 2.2 miles, if it goes 160 meters a day, it takes 22 days to get to Highway 130. If it moves at the 430 meters a day, the higher rate, it's much less, 8 days. But it's a very gentle slope in there. Okay, so if it takes the more northerly route, the 3.8 mile, and we use those same rates, numbers, then it ranges from 39 days at the slow rate to 2 weeks at the higher rate to get to Highway 130. So I remember early on in our meetings here stating with some degree of confidence, I thought, that the lava flow would, at the current rate it was flowing, when it was above Pa'a Street, it would hit Highway 130 within, what did I say, a week, 2 weeks? Came back the next week and said, you know, the lava flow changed. So I urge you to look at these numbers with a great deal of skepticism. They're totally uncertain. But maybe they are help maybe in the back of your mind. Okay, then the last little thing I wanted to share is that one of the most important things that affects the lava flow is how much lava is being erupted at the source and entering the lava tube. And we were able to make some measurements of the lava tube this week, but we were only able to measure the cross-sectional area of the lava stream flowing through the tube. There was no skylight at the measurement site, so we couldn't get the velocity. So we don't really know what the actual discharge, because you need the cross-sectional area plus the velocity. We don't have the velocity. But if we compare the cross-sectional area, almost like the size of the pipe, that size of the pipe is about 50% of the peak discharge in August. So it's still at a much reduced level compared during the first 2 months of this lava flow activity. Okay, so in conclusion, the breakouts from the crack system right near the well site have developed into an organized flow that's moving to the north of the original flow. That flow is following a new steepest descent path, but the future path is uncertain because of that close proximity of those two blue lines, and it may become clear in a few days to a week or two if the flow keeps moving downslope, which path it may start to take. And at the same time, the advance rate, the flow rate, is likely going to decrease because of the more gentle slopes, as long as the discharge doesn't go rocketing up from Pu'ua'o. And the advance rates are likely to become much more variable, uncertain, because of the process we observed during the older flow. Flow may come forward, it may stop for some reason, supply to the tip is interrupted, and then a breakout further upslope, one's going to come down along the side, and that'll go a ways, and then that might stop, and another one. So that means that the advance rate's really going to vary quite a bit, and there's no way to know what those rates are going to be. Thank you for your patience. You've been great. Thank you.